we kind of already know what we're doing. I don't feel like this one's that difficult. But
100.
you've got to remember one specific thing. Ionic compounds is all we're talking about.
You know how much anymore?
Actually, no.
One more problem.
So ionic compounds are a metal that joins a non-metal. That's really important to keep remembering, because this is the only time that I'm going to do this kind of drawing with arrows and dots moving and charges. I'm only going to do that with ionic compounds, because ionic compounds are ions. They have charges. That's in their name. Ions are an atom with a charge. The only ones I'm going to do this kind of drawing with. Now, when a metal joins a non-metal, metals are on which side of the table? Let's look. Let's draw a little mock table. So metals are over here. What charges do metals generally make?
Positive.
Okay, so they're making positive charges over here, and they're going to be joined with these non-metals over here, making negative charges. If metals are generally positive, what do they like to do with their electrons? Gain them or lose them?
Probably gain, probably lose.
Lose.
Probably lose.
Okay. Again, we're talking about electrons. If I'm positive, it's because I lost negative things. I lost negative electrons. So metals like to lose electrons. Always. If it's a metal, it wants to lose electrons and be stable. Non-metals like to gain electrons. That's what they want to do to become stable. Now, if metals lose, they're losing to some. It's not like they just throw them off into space. So if you're looking at this picture here, this metal aluminum wants to lose all three. It has to give it to someone, though. So who wants to gain it is non-metal. So it finds this non-metal that wants to take the electron from it. But if this loses, it becomes positive. If these gain, they become negative. And that's all we're doing is drawing little pictorial pictures of this happening and showing you how many they would need to make it balanced. All you have to do is follow these steps. Just follow them one by one, and you'll get them right each time. So first step says, draw a Lewis dot structure for both elements. So if I'm going to do this practice down here, it's magnesium and oxygen. Now, if you remember back from notes, it's a couple days ago, a Lewis dot structure is just their symbol, so Mg and O, and then they get dots around them for how many valence electrons they have. That's why I went over valence electrons for warm-up. Magnesium is in the second column, so it gets 2. Now, there was a specific way to do those dots, so let's put those on the page so we don't remember. So we do remember. 1, 2, 3, 4, and then it just goes around. 5, 6, 7, 8. Okay, so that's why I specifically put those dots right there, because that's 1, that's 2. Now, oxygen, oxygen has how many?
Oh. -2.
That's not about charge. What column is it in?
16 could be 6.
So it'd be 6. Okay, it gets 6 dots. It's either 6A or 16. It has 6 valence electrons. So it has 1, 2, 3, 4, 5, 6. All right, it has 6 dots. Now, the second rule kind of goes with the third. So I don't really do them separately. I just kind of do them at the same time. It says determine how many of each element you will need for the metals to lose. I want magnesium to lose both those valence electrons, and I want my non-metal to have a full octet, meaning have 8. So I need to draw however many I need. In this case up here, aluminum had 3 dots to give, but chlorine only had 1 spot for it. So I needed 3 chlorines to be able to put 3 electrons somewhere. Now when I'm looking at magnesium and oxygen, I have 2 dots to give away. How many does oxygen need?
4.
How many does oxygen have?
2. Or 6.
Has 6. Its goal is 8. So how many more does it need?
2.
2. Okay. So if I have 2 to give and I have 2 spots to fill, well, they're a perfect match. They literally would be like, they are the perfect bonding combo. This one can fulfill that one's goals and it can fulfill its. So I will draw where those valence electrons are going to go. Magnesium is going to give both his valence electrons away and they'll be given to oxygen. And then all you have to do is redraw it, showing how they end up. So when magnesium meets an oxygen in space, floating around, they bond by magnesium throwing him some electrons, oxygen taking them, They become positive, negative, and stick together like glue, because now they're positive, negative attraction. So magnesium is now empty, not really, it has electrons underneath it, but since I just drew it as it gave it away, I'm gonna draw it as empty. And it has a +2 charge, so it gave away 2 electrons, so now it's +2. When it's bonded to the oxygen, oxygen took those electrons, so now it is filled. I'm gonna show it being filled, having all 8, but when it took 2 electrons, it became -2. That's it, that's the drawn picture. I do have to see the before with the arrows and the after with the charges, both are required. Let's do one more practice.
Like,
I didn't even see it.
so if I get that NG thing, the faucet.
Yeah.
It's recent.
Yeah, you didn't think
Can really see that.
the faucet.
What does it say in?
Remove the faucet.
Here, I'll leave it up, so you're gonna look down.
Yeah, I'm gonna make you drink it. Boy, I wish you would.
All right, so now same thing. I'm just gonna follow those rules up there. First step was just drawing the Lewis-Scott structure. So lithium,
We're doing this on the bottom.
the old answer's on the bottom, I just left it there in case you needed us to write it.
Oh, who's that?
So lithium has 1 dot. This is the first column. Phosphorus is in what column?
1575.
It's in the 15th column. Are y'all seeing that?
Yeah.
Phosphorus in the 15th column, so that's 5. Okay. So I put 1, I put 2, I put 3, I put 4, I put 5. Now, this one does not. It's not a perfect match. So when I start drawing where the electrons are going to go, lithium always wants to lose. Metals want to lose. They want to give them to non-metals. So I put it right here. Well, is phosphorus filled? Is phosphorus happy? Does it have 8? No. It still has a spot. It still has a spot. It's still not filled. It's still not stable. So in real life, this phosphorus would not bond with one lithium. It wouldn't do it. It wouldn't be worth its time. It wouldn't be stable. But if it had more lithiums that would fill its spot, it would make a bond.
Yeah. What if you put the 1 electron person 6th spot?
It doesn't matter. Now, how many more lithiums do I need to fill it?
Hold on.
2, 4,
How many spots do I need to fill?
2.
There's 2 more. How many does this lithium have to give? This lithium only has 1 to give. So if I draw another lithium, it also only has 1 to give. They only always have 1 to give. It's in the first column. So if I show this lithium giving its electron away, fills that spot. The phosphorus is still not filled. So I have to draw another lithium. Give it its 1 dot. When it gives its 1 electron away, bam, now phosphorus is filled. That's how many it needed. So the only way that phosphorus would bond with the lithium is if it had 3 lithium. It wouldn't do it unless there were 3 available. So how that ends up, draw the finished product. We have 3 lithiums, and they bonded to 1 phosphorus. I'm going to draw the lithiums as empty. They're not really empty. They have electrons underneath their valence shell. But if they all lost 1, what is their charge?
+1.
They all lost 1, so they became positive by 1. Phosphorus gained 3. So what is it? -3. Now it gained all it needed, so we're going to draw it being filled. Full and filled. Okay. Now, just as kind of like a showing you what's coming, like why, well, what is the point of this? This is showing you that when I make a compound, it will end up being Li3, so lithium 3, 1 phosphorus. If you've been seeing those little numbers of weird compounds, you've seen them all year, why is it Li3P? Because the only way for phosphorus to be stable is for it to have 3 lithiums. It wouldn't bond with any other number of lithiums. Okay, so that's not coming today, but that will be coming like in a couple weeks. So that's just like the why. All right, so notes are completed. I will leave my Google Meet up, guys, if you need help with your worksheet that you have.